right. In this video, I would just like to demonstrate a couple of more examples in terms of how to graph rational functions. Now take a look at the example 2. Okay, so our example 1, the denominator is just a linear function, but here both the numerator and the denominator both are quadratic functions. Now, first of all, this one is written like that. I would like to change, that's just my personal preference. I would like to change the highest power always to the front. And it's just easier for me to see. So I'm just going to change to negative x to the power of 2 plus x, then plus 2. Okay. All right, so now the first step is always going to determine vertical asymptote and the horizontal asymptote. Okay, the vertical asymptote, it is if we factor this and then it will become this. I'm just trying to keep the video short so I don't do this work. So then in this case, x does not equal to negative, cannot be negative 1 and 2. So our asymptote will be vertically, will be x equals to negative 1 and x equals to 2. Okay. Now our horizontal asymptote, because there's the same power, m, the highest power on top, and the bottom, they're the same. So therefore, will be the coordinate, the leading coefficient, the fraction of the leading efficient, and therefore the y equals to negative 1. All right. Now right away we want to put this asymptote on the graph. Oh, that's usually what I do. So this is a vertical asymptote, and then this is my horizontal asymptote. Okay. So now the second step. So the second step, as I said, I was always want to do the intercepts. So then what is a y-intercept? The y-intercept is, that means when x equal to 0, this is 0, this is 0, this is 0, this is 0. So then that means it is negative 1. So when x equal to 0, and it is negative 1. Okay, so then this is my y-intercept. So then I'm just going to put my y-intercept here. That's I always like to do. All right, so then let's see if, so my y-intercept is 0 and negative 1. And then how about my x-intercepts? That means my fx equals to 0. My fx equals to 0 may mean this 1 equals to 0 because this is just gone. Multiplied by the denominator, both sides, and then it becomes x squared plus x minus 2 equals to 0. So then we factor that. When we factor that, it becomes this, right? So then in this case, we know this is our 2 x-intercept. So then I'm just going to put my x-intercept on the graph as well. So then I got this point, and then I also have this point. Okay, so now I got these points. Now I will start with the table values. Oh, by the way, so our x-intercept here, it is negative 2 and 0 and 1 and 0. Now next one is whether or not we have holes. And in this case we have no holes because we cannot cancel anything, both the top and the bottom. So no holes. All right, so all my graph will be a continuous graph. Okay, so now the third one will be my table of values. Okay. We talked about the table of values. Now, first of all, you always want to see the values that is on either side of your asymptote. So here we go, we can see we have asymptote, which is as negative 1, and the positive 2. So we always wanted to see when the x value is approaching from here and approaching from here, that means approaching from -1, the left-hand side, and -1 from the positive side. All right. Now from this line here, that's 2. So we want to see when x value is approaching either from this side or approaching from that side. So that means approaching either from 2 from the left-hand side or approaching from 2 from the right-hand side. Larger than 2, smaller than 2, larger than -1, smaller than -1. The reason why we always want to see the y value, usually, because definitely the y value is shooting to infinity. Because when your x is approaching 0, of course your y is shooting to infinity. But we wanted to make sure whether or not our y is shooting up to positive infinity or shooting up to negative infinity. So that is a very important thing. For us, we must see the sign. So now, for example, now if we choose from the -1 from the negative side, and then that means this is a really large positive number. So that means approaching from this side, my y is shooting upward. Now this one is approaching from the -1 from the positive side or the right-hand side, and then it turned out to be a negative large number. So then I understand when my x value is approaching -1 from this side, my y value is shooting down. And then I also see, okay, from this is a 2, now from the left-hand side, that is a positive number, and similarly from the right-hand side, and then that is a negative number. So I always want to see the trend, and which is like that. All right? So I also have these 2 points to guide me about how this approaching happens. So then this line is this curve. Now, another value to choose, we said that we know that when x value is either approaching negative infinity or positive infinity, our y value will be approaching to our horizontal asymptote, right? But we want to know when we approach negative infinity, it is approaching from the positive, so it's approaching from the 1, which is the positive, or we're approaching the 1 from the negative. So in this case, now we can see you plug this negative number in, and this is positive, and then you plug this number in that is smaller than 1. So therefore, it's approaching here from negative infinity is from the top of your asymptote. This one, when you approach positive infinity, it is from the bottom of this horizontal asymptote. All right, so these table values, these ones, this is a very important value for us to pick. And then we pretty much then just draw these curves, and we're perfectly fine. All right, now this question I will now be demonstrating because it's very similar to the example 1. Now take a look at these patterns. Now this is also bottom is a linear, this is bottom linear, and on top is not just a constant, it's also linear. Okay, now take a look at the graph, how it looks. I always want to try to see the pattern, but so far it is very elusive, the rational functions. It's difficult to see a pattern. However, this kind of pattern we can figure it out. Take a look at this. This is a quadratic at the bottom, and the top is also a quadratic. Now take a look at this. this one, the y value will always be larger than 0. It does not. It can be equal to 0, but and also this is even no horizontal, there's no vertical asymptote. There's no vertical asymptote, but there is a horizontal asymptote. Why? Because this power and this power equal. So then the graph looking like this when you pick up the some of the points. So when you pick up the points is that you can just see how the trend goes. First of all, we always want to say a big x value, another big x value, positive and negative, and we can see this is because it is a 2. And they both from the bottom, right? They're both negative thing. So then that's what both approaching from the bottom. And then we also know if x, so there's an intercept right here. And then we give some of the values, and then we can pick a 1 and -1 and 5 and -5 to guide our curve like that. Now this one is another interesting question, very typical. So this is, again, this is a quadratic function. And we factor it, then we know this is a 2 asymptote here. And we have horizontal asymptote? Yes, we do. But because this is x to the power of 0, so this is smaller than the bottom. So then our horizontal asymptote is right here. Now, very importantly, you want to see whether or not approaching from here and approaching from here, where is shooting through. And then this one, you also have a y-intercept here, but we have no x-intercept. So that means this line does not go, not only this does not go through the x-axis, and also this one, when you're approaching to positive 2 from this side, it's shooting down. So therefore, it's not shooting up like the other question. So therefore, it is this kind of curve. The last one is this question that from here, we can cancel this x minus 2. So therefore, at the x equals to 2, there's a hole. All right. I won't demonstrate this question because it will be just too tedious and too long. So please take a look at this question. Make sure you understand the whole. So there's still the curve is like this, but there's no value right at this point because x cannot be 2. Okay, well, thank you for watching.